Thank you.
Hey, good morning, everyone. We'll see if my slides work too. So admittedly, it's going to be a weird place to start, but I want to start by talking about Stoicism. Don't worry, you're in the right room. So Stoicism in broad strokes, it's all about accepting what we can't change. And accepting and getting up, excuse me, I'm now all over my place. Accepting what we can't change and dealing with adversity with calm and composure. And as long as I can remember, going all the way back even to childhood, I thought of myself as a Stoic. Now, it is kind of a weird thing for a 10-year-old to consider themselves a Stoic, but that is certainly a topic for a different talk, or maybe therapy, one of the two. But anyway, so there's, I'm so sorry. So Stoicism. In Stoicism, there is this concept that discomfort can be a teacher. Now, whether or what kind of thing is teaching depends on, of course, whether or not you can control the thing that's causing you discomfort. Now, for things that you can't control, discomfort is a teacher of resilience. It's a teacher of composure. It's there to help you learn how to deal with those things, that adversity, while remaining in equanimity. And of course, determining what you can and can't control is going to be the really important part. Because for the things that you can control, discomfort is a teacher instead of focus. It's there to help you see the things that you can change and to make a commitment to making them better. So if we go back here, I want to invite you to take a moment with me to think about something in your life right now, something hopefully in your work life, that is a little uncomfortable or a little bit frustrating. Now, it doesn't have to be something that has to do with data, but since we're talking about data and JMP, it will be helpful if it is. And I know that many of you are here with coworkers, and so if it's something you share, that's probably good too. Actually, if it is your coworker who is here, maybe pick something different. So take a second. I'm going to do the same thing. So again, something that's causing you frustration or discomfort right now. All right, so all of us have to make a choice. We have to make a choice of how much we're willing to invest to make change or to fix the thing that is making us uncomfortable. And that, of all things, brings us to the JMP ecosystem. Because the JMP ecosystem and JMP is incredibly good at helping us through discomfort or helping us through frustrations. And the great thing is, if JMP is not perfect for the thing you're trying to fix, it actually gives you the tools to fix that discomfort on your own. And actually, it gives you the tools to do that with the least investment possible. So let's talk about the JMP ecosystem. So on the surface, we have platforms and tools that we work with interactively. And I like to think of these as literal platforms across the JMP landscape. And so platforms exist as largely independent structures, each of which serves a purpose around some kind of data, some type of analysis, some sort of application. But below the surface, below all these platforms, sits the vast ecosystem of statistical algorithms and routines that we operate on by way of the platforms. But of course, lucky for us, we don't have to deal with the statistical machinery. We get to operate on them through the JMP interface. But the JMP interface and interfaces in general do have potential issues. All of them suffer from this, which is that if the designers of the interface didn't build the thing that you need it to do, oftentimes you're stuck. That is, you have to turn to some other tool. But JMP has actually had an answer for this for quite a while, which is to build an actual interface to extensibility. And so what I want to do right now is invite our founder and JMP architect, John Saul, on stage to tell us a little bit about JMP's interface to extensibility. So John?
Thank you, Julian. Well, one of the key technologies to customizing and extending JMP is, of course, the JMP scripting language, or JSL. So this happens to be the 25th anniversary of JSL. So let's take a little look at some of the history. When we first started JMP in the first few years, we never thought we needed a scripting language. The whole idea of JMP was interactive user interface. We were trying to get away from scripting languages. But then we felt stresses that led us to creating the scripting language JSL. So the stresses included we needed a language to express formulas that was editable as text. So if you double-click on a formula, you can edit it that way. We needed a way to save analyses. What better way than to save them as scripts? And we needed a way to extend JMP to do the things that were not built into the product, to extend JMP. So JSL was born in JMP 4 back in the year 2000. We needed all the functions and operators that would be needed in formulas in the data table columns. We needed to allow spaces and blanks and names, and that affected the design of the syntax because we had spaces in the menu items and the commands and the column names and so on, and so we needed to support that. And we needed an object-oriented operator, the send operator, to send commands to an object. And we needed rich objects, numbers, strings, matrices, lists, associative arrays, scriptable objects, and so on. And those are the ingredients that led to the founding of JSL. And several key breakthroughs connected scripting to everything else. First, the internal objects in JMP, like platforms and data tables, had a uniform scripting interface that included used the same structures used by the interactive menus. So this ensured compatibility between scripting and interactive use. Everything you could do interactively, you could also do through scripting and vice versa. The display system itself was made scriptable so you could navigate, obtain information, and send scripting commands to the display. And also, each object could manufacture a script that could reproduce itself, allowing users to save scripts to reproduce results. So those were the characteristics of JSL. And when we first came out with JSL, we decided to do some demonstrations. And one of them was this interactive kernel density estimate. And so in 20 lines, we were able to express a demo on how kernel density estimates are formed. Notice that there's a Y function, which can draw things in a graph. And the function that it's drawing is the normal density function centered at each data point with a bandwidth of sigma, the standard deviation argument. And so it draws those 20 or so normal curves in black. And then the kernel density estimate is just the sum of those, the sum from I equal 1 to n of the normal densities, and that's the red line that you saw. And so we can animate then with the scroller to show how changing the bandwidth affects the kernel density estimate. So then, after the initial release, JSL has evolved over the years to embrace many new powers. One of the big breakthroughs was to be able to store scripts inside data table cells. We wanted to enrich the ability to store complex data in these data table cells. And so columns could be expression types. And when you store an expression type that delivers an image, then it displays as an image. And this allowed us to do things like an internet open command that when you import web pages, like this Wikipedia page of the current United States governors, then it can include a script that then materializes the images, retrieves them from the web page links to make something that looks pretty much like the Wikipedia page, but now it's a JMP data table. And as a JMP data table, you can do all the things that you can do in JMP, like make graph builders. And here's a graph where the state is on the y-axis and the date born is on the x-axis. And you can hover over a point, and if you take that image variable, that image column as a label variable, that includes it when you hover over a point. And of course, you can fix those. So that was one of the breakthroughs. Another breakthrough that I really love is patterns. You probably haven't used this, but it's quite powerful. In fact, when patterns were first developed by Craig Hales, a developer, he wanted to support not just regular expressions, but a set of operators. And his demonstration program was to build a Fortran compiler that compiled Fortran programs into JSL. And its demonstration was to take a very long Fortran program called the Colossal Cave Adventure, an early game that was text-based, and implement it in JSL by compiling the Fortran program. And so this was quite pioneering. The older among you probably remember this game, a maze of twisty little passages and the secret X, Y, Z, Z, Y, and so on. And then when we implemented 3D graphics to support the scatter plot, the 3D scatter plot, we also interfaced that to JSL. And Craig even implemented a little rat maze game where you could navigate something that had both a rat's eye view and an overhead view. And then soon after that, he implemented the socket interface, and that allowed it to become a multiplayer game. So a multiplayer game just in JSL in the early years. And he even wrote a primitive web browser in JSL that used that socket interface. So great power as JSL grows up with the data types, associative arrays, images, patterns, blobs, namespaces, a script editor, the scripting index, the JSL debugger, the JSL profiler, XML and JSON parsers, and then, of course, add-ins and the file exchange, where you could share, easily share scripts that built things that were interfaced directly to our menu system. An app builder and dashboard builder. And in Jump 16, action recording, so that everything you did interactively could be saved. And once that ability was materialized, then workflow builder, which Julian pioneered, came out in Jump 17. And in Jump 18, the scripting language has a sister now. And so you can program not just in JSL, but in Python. There's a built-in version of Python now in Jump. So JSL, 25 years, and it's grown up. And the key to extensibility. And of course, with Python, there's a huge open source library of programs and interfaces available, and a generation of programmers already trained in Python. So back to Julian.
Thanks, John. So as John described, JSL is really the interface to extensibility we have in Jump. And I think one of the best places to start is actually by using JSL and using that extensibility to give a path or a map of what we do in the software. And visually, I like to think of this as literally navigating the environment and keeping a path or a record of our navigation through it, what we interact with, what we turn on and off in the interface, the operations that we take. And what's great is that Jump is actually capable of keeping this map for itself. It's able to watch where you go and keep a log of it that you can replay later, which is useful for recurring tasks where you might want to just save some time and redo the thing you've done before. And so I want to show you in Jump a few ways that this surfaces for us. And so what I'm going to do is take you through something I've been working on recently. This is actually working through some of my Apple Photo metadata. And so it's called EXIF data. And I'll actually share this with you all if you want, this workflow. But there's this great terminal application. It's just called EXIF tool. It'll rip through your photo library and pull out all the metadata that's part of the photos and spit it out as a CSV, which is really great. And so let me just run this, because this is a workflow in Jump. If you haven't seen a workflow is just that record. It's that map of your interactions with the software. And I have some stop points here, because I want to stop and show you before any of the data preparation happens, just how awful this data table is. So let me put it up here. So this one is 1,700 columns. It actually depends on what other data is in your photos, but for at least the iOS photos, 1,700 columns, pretty darn sparse, which is pretty infuriating when you're working with data, because you end up looking through columns to figure out what is actually useful and what you want to keep around. And for that many columns, it just becomes quite annoying. So what I had done here, though, in the workflow is I recorded all my steps before, where I go through, I delete some columns, I group some columns. You'll see now my table is a lot more reasonable with 77 actually usable columns. And I actually have columns in groups here, so organized by things like date and time and capture dates. And so this totally handled this process for me, and this is something that I run repeatedly. You'll actually see at the start, I have this SSH trigger. I remote into a different machine to have it export my photos, because my whole library is on that machine. And so this is something I actually capture quite a bit. And so the data is great. I highly encourage you to do this yourself. There's great things like what lens you actually took the photo with, which is quite fun. Let me show you real quickly. I'll just put this into Graph Builder, and I'll use a different tool and jump a preset. This is just like a pattern you've built based on something you want to show. And I'll turn on packed bars. And so you can see what kind of lens you used. I can see I took it mostly with my iPhone 7. Really cool stuff. But anyway, what I want to show you right now is actually let's build another step in this workflow, because the thing that I thought about that was frustrating to me was these geographic columns, or actually a single geographic column that the metadata writes out with the latitude and longitude. And every cell is both the latitude and the longitude, which is not particularly useful if you want to graph, right? We got to separate these things out. So let's actually just process this right away. I'm going to hit record, and let's add a new step. And so there's a couple things we have to do. I'm going to first recode, because what I need to get rid of are the DEGs. I need to replace those with the actual degree symbol. And so I'm just going to use the replace string, and I'll say replace DEG with, and I have to bring up my emoji keyboard. Actually, let me just copy it from here. I'll take that symbol. And so we're going to replace the string, the DEG. All right, so that's the first step. And I'll actually do this in place, since I don't need to keep that old column. And then we need to break it apart. And so you'll notice there's a comma delimiter I can use here. So I'll use columns, utilities, text to columns. So again, JMP's really great at reducing frustration because it has so many tools built in. And the last couple steps here, we actually have to make these true geodesic columns. I'm going to set them both to numeric, set them both to continuous, and I'm going to change their formats to a geographic degree minute seconds for latitude and degree minute seconds for longitude for the other one. And then finally, we have to do name changes. I think GPS position 1 and 2 is not that great. Latitude and longitude. Oops. Oh, I spelled it correctly. Win. OK. I'll hit the stop here. And so you'll notice it's actually captured all of these steps to the workflow. And so if I were to rerun this, this would all rerun, and it would actually recreate those columns as I've made them here. But I want to show you something that I like to do, because again, we're doing workflows as a way to do current work, keep a record, but also to make future work easier. And so one of my favorite things to do is to make a utility workflow. Anytime I do something that I think I might do later, I'll actually make a separate workflow. Let me take those steps, and I'll just drag them over to it. I can delete them out of the original workflow. And what I'm going to do is I'm going to call this let me save it here, to my utility workflows folder, where I have a bunch of these. And I'll call this like geo columns, and hit save. And so what I can do now is from my processing EXIF workflow, I'm just going to include that. So I'm going to reference it, and I'll say include this workflow. And I'll point it to my geo columns workflow, which I just made. And so what this does is it's a sort of a level of indirection. This workflow can just exist out there, and that gets included whenever I run this workflow. So I'll say process geo. And just so you'll see it actually does what I say it does, let me move it up here. I'll restart, replay. It's going to do the same import. Then it's going to wait for me to delete those columns. I'll let it play. You saw it popped up that workflow to include it, and then it kept going. And so what's nice about this is anytime I want to actually process geographic columns like that annoying function or structure that it produced here, I can just let that workflow run. And now I can actually pop into Graph Builder and do something with these. Put latitude and longitude. I have another preset here called, I think I called it classy map. Sure. So I'll turn on my classy map. And then there we go. And so now I can zoom around and look at places I've been, and don't worry about that point. I think that's 0, 0, which is why it's there. I have not been off the coast of Africa. At least I don't remember doing that. So, but in any case, so workflows. Remember your path through JMP. So JSL is really that ability to capture that and to bring you back to right where you were, and to reduce that frustration so that you don't have to work through it again later. So our map. But sometimes, the landscape that we have locally to navigate isn't everything that we need to do. And so what I want to do is invite up another speaker to talk through a case where what we need to do is reach outside of our local ecosystem, outside of our local platforms, to bring something else into our workflow. So I'd like to invite Caleb on stage to tell us a story about that. Caleb?
Thanks, Julian. All right. MSAs are good, but they can be better. So I'm Caleb King. I'm a developer in the Design of Experiments and Reliability group here at JMP. And today I'm going to show you what I think is a pretty unique illustration of JMP's integration with other software, in this case, R. Now, I know it's in bad taste to use acronyms before they're officially defined. I apologize. I expected a lot of Design of Experiments folks here in the audience, so I figured you might know what an MSA is when I call it that. But for the rest of you, I'm going to go ahead and define it right here. So what is a metropolitan statistical area? Thank you. All right, so when I'm not doing Design of Experiments, I'm a big map nerd. I like geography. So what is a metropolitan statistical area? Well, you actually are kind of familiar with it. When you refer to things like the New York metro area, Houston metro area, Los Angeles metropolitan area, those are informal terms for what is here defined a little more formally. This is defined by the Office of Management and Budget, OMB. It's the government. They like their acronyms. And it's built by combining counties that surround one or more high population areas and are connected based on some threshold of commuters to and from those counties. And they're often used for economic analyses, so housing, labor markets, any other type of studies that involve sort of these urban areas. Let me show you some quick examples. Here are 5 that are kind of important to me. The green one there at the bottom, that's us. That is the Raleigh-Cary, North Carolina Metropolitan Statistical Area. Up top in orange, that's the DC capital region. I was just there this past weekend. Lots of traffic. And then here in the middle are 3 very important to me. So the one to the right in red, that's the Lynchburg Metropolitan Area. I spent a good portion of my time growing up in Appomattox. That's about 30 minutes from Lynchburg, but it's in that area. In blue is Blacksburg. That's where Virginia Tech is located. That's where I went to grad school. And there in purple in the middle, that is the Roanoke-Salem metro area. That's where I live right now. Now, out east here, these seem to be reasonable. They cover a lot of space, but the space they cover seems reasonable. Let's go out west. Now here I'm going to focus on what's called a micropolitan area. It's the light green shaded areas. They're like metropolitan areas, just less population. Let me highlight one here for you. Here's the Show Low micropolitan area. Here's what it looks like in Google Maps. That's Navajo County in Arizona. And I don't know about you, but I don't expect everybody there to travel all the way down here to the mighty hopping metropolitan area of Show Low. So that might not necessarily be very accurate, very representative of that area, but it's the county. That's how it's defined. Let me show you another one. Here are the 3 areas that make up the Los Angeles Combined Statistical Area. They're a fancy name for combining metropolitan statistical areas. Let's look at the one here in green. That contains actually the largest county in the lower 48 states. That's San Bernardino County. Here's a map of what that looks like. You'll notice most of it is the Mojave Desert. Where's the city part? Well, it's right there in the corner. So there's that part of the metro. So we can see a clear issue here that these may not be as representative as we'd like. Can we do better? Well, I think maybe we could. What if we used a different geography to make these metro areas? We could use census tracts. That's one step below the lowest. The lowest is a census block. That's the lowest resolution. It's basically the size of a city block. Let's go one step up. Maybe we can get better resolution using that. And also, let's be a little more formal. Let's not just define a threshold, an arbitrary threshold. Maybe we can actually create a commuter network and then do some clustering or community detection on that network. Now, you may not know this, but JMP currently doesn't have any network analysis capability. Hopefully we can push on that. That would be something great to have. So that's where the R piece comes in. R actually does have a package called iGraph that allows us to do this. Now, in order to do this, we are going to need loads of data. Thankfully, as you can see, I found a place that has loads, L-O-D-E-S, of data. So this contains commuter data at the census block level based on some surveys. Now, at this point, I'm going to transition over to JMP. Whoops. Pay no heed to the table. So I have here a workflow. I'm not going to run it. It does take a little while. It doesn't have the 1,700 columns that Julian's table had, but it does usually have 20 to 30 million rows. So I think I've got to beat there. but it does take a little while to process. So the first part, I'm going to focus on the state of Arizona. And I'm just going to quickly run through. I'm not actually going to run it. Hey, look, blobs. Jean-Saul mentioned blobs. So it basically goes out, picks up the data, and it's going to summarize it. I'm going to focus only on the states and their immediate neighbors. These don't have to be within the states. They can cross borders. That's fine. But we don't want to have too far connections. So, all right, I make a simple network. Where's the R part? It's right here. And it's very simple. I just initialize R, tell it, here, hey, here's the data table I want you to work with. This is my simplified network. R takes it, does the thing, does the clustering, gives me back a data table. Now I'm good to go. I save that, and I can manipulate it where I want. Very easy. Now, not only do I use R for the actual clustering, I can actually use R to make the maps. Because what I can do is go out. There's a package in R that has shape files for these census tracts. So I have it go out, pull that shapefile information in, merge them based on the clusters, and while doing that, pull in some population data and some other metrics that you might find interesting. So that's all, again, done here. It's a little more involved simply because I have to do it for each neighbor and everything, and merging and pulling all that information. But once I do, I can output that as the shapefile, and there are actually ways in JMP to take that data and actually map it out. And now that's where the data table that I showed you earlier comes in. So here's the final result, at least for this state. So it found 16 areas. Let's plot that. What does that look like? Here I've color-coded them based on population density. We have locations of different areas. Population density is a more fair comparison. We see some interesting things. We're all about statistical discovery here at JMP. What's this big hopping metropolitan area over here? Well, it's actually kind of part of the Phoenix area. It's a little artifact, as I call it. It's a military base. So apparently, in the commuter data, whoever is going there is primarily coming from Phoenix, so it said they were tied. Okay, we can maybe address that. Here's the actual area around Show Low. That's a little bit better. So what happened to the rest of it? What's up here? This is part of the Navajo Nation, which has headquarters over here, or at least some headquarters, admin facilities here in Gallup, New Mexico. That's the connection. One other region I want to highlight real quick. What is this one? This guy. It wasn't part of the other one. It was below it. But that actually makes up the San Juan Reservation completely. So in essence, not only have we perhaps found a better resolution in our areas, but perhaps better representation of underrepresented groups as well. Very fascinating. Well, I've kind of run out of time to describe this, but if you'd like to learn more, I'll be at the expo. You can talk to me about that, or design of experiments and quality and reliability, all that. That's important too. And so I love to talk about this stuff, but at this point, I'm going to go back to my slides and pass it on back to Julian. Thank you.
Thanks, Caleb. So workflows and presets, too, allow you to map your path through the JMP ecosystem, or even sometimes outside of the JMP ecosystem, as Caleb told us. But sometimes it's not a matter of needing to get outside of JMP and bring things back. It's sometimes a matter of JMP needing to play up here, the JMP ecosystem, to other tools. So sometimes it's about connecting this to other things outside of it so that JMP can play nicely along with things outside in the world. And so our next speaker is going to tell us a story about doing just that, having JMP act as a peer or a piece of a larger data process. And so I'd like to invite Dan Valenti, our Director of Product Management, to tell us that story.
Good morning, everybody. As Jules mentioned, I'm going to talk about a workflow that lets us kind of connect to other tools and really enable us to find different things in data. So at JMP, you know that we like data. We also love our customers. And as you know, Discovery Summit is the place for us to combine our two loves. So if you've been to Discovery Summit in previous years, you may recognize our interactive wall that started here in Cary in 2018. So this activity has Discovery attendees answer fun, interesting questions that then turn into a physical representation of a statistical visualization. So as you can see in 2018, Discovery attendees answered questions to create a parallel plot. So we continued this activity over in Copenhagen, and even John got in on the fun. And then later in 2019 in Tucson, we actually added another interactive data activity where attendees built a histogram with ping pong balls. And you can see one of the attendees there walking up and placing the ping pong ball to build this histogram over time. Now, here's the thing. Not everybody is as serious at the activities as all of you are. So I wasn't going to include the slide, but Jeff did offer to pay me some money to show off his skills. So I don't know if he's going to come out and make good. Otherwise, I'll pass the video. But until this date, no one believed he did this. Oh, thank you. I appreciate that.
Sure.
And then there was a brief hiatus, nothing going on during that time. But in 2024 in Discovery Manchester, we introduced the analytic workflow interactive wall earlier this year. So in there, attendees put stickers to represent time that they spend analyzing data in different capabilities in the analytic work. So we're continuing that this year for Discovery and Carry. You will soon see that we have the same activity that we did in Manchester. However, we asked ourselves, what could we do to show these activities are not far from the work that you all do on your daily basis in your organizations? Essentially, we said, how can we analytic workflow to the JMP analytic workflow? And so if anyone knows me, in typical Dan fashion, we may have over-engineered it. Let me tell you how. All right, so here is the interactive wall data flow. So you are the data source. You're going to be putting stickers on the wall to help share how you use the JMP workflow in your daily tasks. Then, of course, we built some cloud infrastructure that allows us to easily digitize the results by entering them into a web form. Those forms get entered into a database on AWS. Then we can build a query builder script that can bring the raw data into JMP, clean it up, build some additional columns and features for analysis. We'll analyze the results and get a standard set of visualizations. And now we can publish those results to JMP Live. Now that the results are published to JMP Live, we can remove JMP from the equation because we can set up a refreshable data script so that whenever there's a new entry into the form and the database gets updated, that JMP Live report gets refreshed, and then the resulting reports get up to date. So the cool thing here is you can follow along during the event instead of having to wait until the end of the event to see what the data looks like. So the other good thing about this is we do these discovery summits around the world, and now that we've built this infrastructure to collect and digitize those data, the additional lift that we have to do the next event, we'll be in Japan next month to do something similar, is very low. We just set up a new report in JMP Live, we point it to the different database table, we run the script, and then here we go. So we may have over-engineered it, or did we? This is really typical of the workflow that a lot of our users go to bring from raw data to shareable insights. So you can see this is our wall, comes in through a database. We do a number of steps in the JMP analytic workflow, and then we publish those results to JMP Live and keep everything up to date. So this is very similar to the workflow that you might employ. Your data doesn't come in the form of stickers, of course, but your data comes from your labs, manufacturing facilities, simulations, experiments, or other customer surveys. Similarly, your workflow starts with raw data and then moves through a set of analytical capabilities in order to turn that raw data into shareable insights. For JMP, the best way to share those shareable insights is with JMP Live. And then this means that everybody has up-to-date analyses, even if they aren't JMP users. And that means working the global clock to share with decision makers in New York or manufacturing facility in Europe. So what may be perceived as over-engineering is really just efficiency. And with JMP's workflow and the ability to also work with different cloud tools and databases, you can really increase your efficiency no matter where your analytic workflow takes you. So we hope you participate in the Building the Wall together during this event. And this QR code is actually goes to the JMP Live report. So if you want to scan that, it'll also be shared in the app. You can see the report updating in real time and follow along, and let's build something fun together. So with that, I will hand it back to Jules. Thank you very much.
Thanks, Dan. So JMP is really built to play along nicely with other ecosystems and other tools. And we hope that everything you need is inside of JMP and already built. But if it's not, that's okay. Remember, JMP has an interface as well to extensibility by way of JSL. And the power of that is that JSL and that interface can reach down into the same core analytic tools, those statistical routines that our platforms do. So JSL can access them as well. And so what that means is you can build up from those same core underlying tools interfaces of your own that can look and feel a bit like the own JMP interfaces that we build in C++. And so that power means that you can build on top of what JMP already offers to do the thing that you need it to do, and to build those interfaces to your own analysis tools all on your own. And so our next speaker is going to tell us a little story about doing just that, integrating as well some Python tools into that interface. So let's welcome to the stage Evan McCorkle.
Thanks, Julian. So Caleb showed a little earlier how we can use external tools like R to do data analysis and data prep within JMP. We can also use external tools like, say, Python to build within JMP and on top of JMP to have JMP do something beyond its existing capabilities. And so that's what I'm going to talk about now. I'm going to talk about a add-in that I developed for JMP 18 using JMP 18's new built-in Python integration to do physical unit conversion. So this is a problem I often encounter when dealing with data. I've got some data in metric. I want to convert it to US customary units or vice versa. And so in the past, I had often used a library in Python, a package called Pint, that has a database of physical units and the facilities to combine them into complex units and convert between them. And I decided I wanted to take that capability and bring it into JMP. So I'm going to start here in Excel. I've got this Palmer penguin data, and this is a subset of it that's available in JMP's sample index. And I'm just going to bring this over into JMP. And so now we have a JMP data table. And we can look and see we have information about different species of penguins, measurements of their beaks, their flippers, their body mass, etc. But if we look at these measurement columns, they all have parenthetical units in them. And I don't want that. I want the units column property. So I'm going to go into this add-in and say detect the column units. We've renamed the columns, and we've pulled those units into a column property. And oh, by the way, behind the scenes, through the Python integration, we're going into that Pint library and verifying that those units are known and understood and that we can work with them. I'll say OK. Now if we look at the flipper length, we can see we're building on top of the units column property within JMP. But we can also build on top of other column properties. So I'm going to add an axis reference line here, and I'll say 200 millimeters. I'll call the boundary for short flippers. Let's say OK. We can look at that in Graph Builder. So we can see that reference line on flipper length, and we can see the penguins weigh between 3 and 6 kilograms. So what if you wanted to show this to someone who's more comfortable with US customary units? So we can do that as well. So let's go back to the data table and say convert column units through the add-in. So here we're seeing flipper length is in millimeters. Let's convert it to inches. While the GUI, the user interface here, is built in JSL using display box components, behind the scenes we're using the Python integration to do all the heavy lifting, to understand the inch abbreviation, to look it up, to understand that millimeters are convertible to inches, and also to do the conversion and show me a preview just like you would see in tables subset or table summary. Also, we see that all the column properties, like the axis reference line I added, were also converted. So I want to do this conversion in place, and I'll also come and do the same thing for the body mass. We'll convert that to pounds, and also do that in place. And so now we can go back to Graph Builder and see that those short flippers are just under 8 inches, and that the penguins are between 6 and 14 pounds. So somebody might be more comfortable looking at the data this way. So we were able to take something that existed out in the world, like this Python package with this database of units, and we're able to pull it into JMP to extend JMP to have the software do something it hasn't done before, and to do that in a way that feels familiar and cohesive to other users of JMP. So if you want to know more about how I did this, you can come find me at the poster session later this week. But for now, I'm going to pass it back to Julian.
So clearly JMP in the right hands and JSL in the right hands makes JMP extraordinarily powerful. But I actually want to say something a little bit bolder about the ecosystem, and that's that JMP, I think, is the best environment in the world to build visual applications for data. And it's a bold statement, but I think it's true because of all the affordances of the software and the way it's built around this interface to extensibility. Because it's not just small applications you can build in JMP. You can build truly enormous applications using JSL on top of all the existing statistical machinery that JMP has to offer. And so our next speaker is going to tell us a story about doing just that, building an enormous application on top of JMP. And our speaker is Drew, who's on the team that develops the biggest JMP add-in there is, JMP Clinical. So let's welcome Drew to the stage.
Developers, 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 developers. If you've been around the computing industry since the 90s, you may recall that little outburst. That was how Steve Ballmer, then CEO of Microsoft, closed out the keynote address of the Windows 2000 Summit. It felt appropriate to invoke that memory and energy here today. In particular, he said, provide developers with the tools to seize on the next opportunity. And with JSL, JMP's integrated scripting language, you can build your JMP ecosystem to do just that. Many of you rightfully think of JMP as an analysis tool. Incredibly powerful, easy to use, highly interactive, point and click, right out of the box, and with a few clicks, you are gaining insights into your data within minutes. You're not wrong. However, what often gets overshadowed is that with JSL, it is also a highly capable platform for building applications, from simple tools that ease repetitive tasks like you've just seen, as well as large multi-user systems with user interfaces that are highly relevant to end users, especially those users that may be overwhelmed by all the analytic capabilities within JMP. But can you really build a sophisticated application with a scripting language? I'm here to tell you unequivocally, yes. JMP Clinical is such an application. While it is sold and installed as a product alongside JMP, JMP Pro, and JMP Live, under the hood, JMP Clinical is just a highly sophisticated JMP add-in. We often joke that it is perhaps the world's biggest add-in. Let me give you a quick demonstration of the user interface that is JMP Clinical. So this is what the end users get to see. They are not overwhelmed by all of the complexities and capabilities of JMP, but rather they are presented with just what is relevant to their usage. So you have patient profiles and study flow diagrams, study visits, adverse events for analyzing studies. So here we can see a study flow diagram that shows you the health of the study, where subjects are in a given state. The subject visits, how they drop off over study visits over time. Adverse events distributions, as well as exposure summaries. I believe JSL and all the functionality it can drive within JMP are an outstanding platform for building applications. Here are my top reasons for making this assertion. Compatibility and flexibility. JSL is the Swiss Army knife of programming languages. Object-oriented, functional, expressional, scripting. You get them all. This lets you leverage the complexity of your code as appropriate to the level of complexity each system or subsystem requires. Simple things should be simple. Complex things should be possible. Alan Kay made that statement in the context of software usability. I think it is just as applicable to software design and development. The subsystems of JMP Clinical that require strong data encapsulation, prototyping, polymorphism, are all built using the object-oriented class constructs within JSL. These include the management of studies, domains, variables, as well as many of the UI components, like each report. that gets reused and have additional functionality that extends beyond the default behaviors. For simpler single-purpose operations where performance and consistency are crucial, we have libraries of functions. The libraries are organized into namespaces, which mitigates name collisions and provides context for usage. JSL itself is an expression-based language, and actions performed in JMP have an expressional representation. When you save a script to script window, you are getting the specific expressions that build that platform, graph, or table. The expression manipulation functions, eval_expr, extract_expr, substitute, etc., let you programmatically alter expressions to build libraries that are generic and can account for different data. All of the reports in JMP Clinical are written in this way, with many of the commonalities between reports being refactored into expressions that get reused across the reports. In addition to the usual looping, conditional, dynamic typing, and structural elements you would expect in any scripting language, JSL also has a very powerful data table scripting capability. Columns, rows, and cells can be referenced individually or in ranges for both reading and assigning values. It is a very performant way to parse and manipulate data. We use all of these capabilities throughout JMP Clinical to glean metadata from the study data or build derivative values where appropriate. Integration and interoperability. Run program, socket, HTTP request, built-in JSON and XML parsing, ODBC data connectors, and as you've seen with Evan's last example, the improved functionality of Python integration with JMP 18 allows you to marshal data types on both sides. You can push-pull data to and from virtually anywhere. JMP Clinical uses these integration points to leverage Java and Python libraries for adverse event narrative generation and accessing a public domain data source that tracks all holiday dates for every country. Additionally, using the SassPy Python package, we've created an add-in we are sharing with the JMP community that leverages Sass's proc report and ODS features for generating 3-line tables in RTF from RTF JMP Tabulate. Finally, publishing and visibility. With the availability to publish to JMP Live, your application can create analysis content in a complete ecosystem, combining the best of easy-to-use, highly interactive, robust desktop application, which is also deployable in the cloud, with a web-based presentation collaboration portal that is JMP Live. In keeping the simple things simple and complex things possible, being able to publish your application's content to JMP Live is a great way to engage a broader user base, giving them interactive access to graphs and tables, all from a web browser. Every report in JMP Clinical has the Publish to JMP Live feature built in. With reports like study flow diagram, medical query risk reports, study visits, exposure summaries, and many others, medical monitors and regulators can be given regularly updated views into the health and status of ongoing study trials. So if you have questions, I'll be around at the developers and meet the experts while you're here this week, so please come find us. Thanks. Back to you, Julian.
Thanks, Drew. JMP really is the best environment to build visual applications for data. But we're always thinking of new ways to add to that interface of extensibility. And so I want to invite John back up here to talk through a new framework that's coming available in JMP 19. John?
Well, one aspect of customization and personalization is style. Now, even since the early days of JMP, you've been able to express preferences for fonts and background color and many other things. But in JMP 19, for next year, you'll have even more control on the display by adding spacing and conditional control with a feature we call JMP Style Sheets, JSS, named after the cascading style sheets that do this role for web pages. Now, I put together a script that expresses the same report in 9 different styles. So let me run that. So first we have vanilla JMP. We lightly shade the background so that the graphs stand out. We also try to squeeze as much as possible on a page in order to reduce the need for scrolling. but you might want to space things out a little more. So there's a style called Comfortable. It's built into JMP 19, and this tab shows that more relaxed spacing. Here's squeezed, and here's relaxed. Okay, looks better, but it doesn't fit as much on a page. Well, what if you really want to go out in high style, say with a salmon-colored background, with stylish green-tinted content and a very distinctive titles in Zapfino font? Here you are really making a style statement. Too extreme? Well, let's tone that down. Say you're a forest scientist, like our keynote speaker last year, Suzanne Simard, and you want dense green backgrounds and a papyrus styling or titling, very natural looking. Or maybe you're a Barbie fan and you want pink tones with noteworthy titles, fabulous. Or maybe your style is vampire, using the same theme colors as this Discovery conference, actually, with luminary titles, wicked cool. Or maybe your style is steampunk, with industrial tones and typewriter font titles, very retro. Or if you really want attention, you might go fluorescent style with these vivid colors and Comic Sans titles, a dazzling report. One more title or style, camo, with camouflage colors and chalk duster titles. Not only that, we put in a random element. So if I re-show it, it changes the color, because with the camo style, and this is all the JMP style things, there is a background color that's uses random uniform in a certain style. Okay, so express yourself in JMP 19 with JMP style sheets. Back to Julian.
Thanks, John. So we spent a lot of time already talking about the affordances of JMP software and the JMP ecosystem itself, and how you can adapt it to your needs, especially when your needs are different than what we've built it to do. But there's another part of the JMP ecosystem we haven't talked about yet, and one that's critically important. And that's the community, all of us, and all of the users everywhere who use JMP. Because communities and people are a big part of ecosystems. Ecosystems are, of course, made up of individuals. And how we interact and support each other affects the overall efficacy of the entire ecosystem. So at JMP, we've long been committed to the community and the user community. Not just community.jmp.com, which, of course, is a huge investment on our parts, and your parts, too, but just the idea of bringing together JMP users to support each other. And so our next speaker is going to come up and tell us about a new investment we're making in the community of extensibility, helping users help other users with their innovations and their extensions. So I'd like to welcome to stage Kristen.
Thanks, Julian. Hi, everyone. My name is Kristen Slappy, and I'm the director or the manager of R&D for the JMP Marketplace. So really excited to share it with everyone today. It's launching today at Discovery, so excited for everyone to get to see it. To get there, you go to marketplace.jmp.com. And the idea for the JMP Marketplace is we wanted to make it easier than ever for you to extend and enhance your JMP experience. So whether those extensions are add-ins, data connectors, camo style sheets, whatever it might be, we wanted to make it easier than ever for you to share those with your colleagues and search ones that have already been created that might fit your use case. So I'm going to kind of quickly demo our marketplace, but again, I encourage everybody to check it out. We wanted to make the interface very similar to what you would expect from an app store. So we started off with our quick search bar. So if I was looking for something maybe in a data analysis role, I have that option there. If I was looking for something in a specific industry, say I work in the academic industry, and I wanted to see what resources were available to me as a JMP user that have already been built that I can quickly install, I can see those easily here. We also have the option to see the ones that have been created by our JMP staff members. And What else can you expect to see from the home page? So we have a couple of featured add-ins that have been chosen by our product management team. They will continue to cycle throughout the year, so we will highlight different ones. And some of these are some of our cool new Pythonic add-ins that have been created for JMP 18. And so both Materials Informatics and Torch Deep Learning are two of those. Capability Explorer is a really fun one that allows you to quickly see a summary of all of the available tools and tools for JMP that we'll go through that in a second. And then for analytics maturity assessment, so very similar to our interactive wall, really understanding your data analytics workflow. But there are over 30 already available that have been created by our JMP staff members, including the unit conversion one that Evan demoed earlier in this talk. Additionally, you can see quickly, ratings and reviews. What are the star ratings for each of these? Understand, what are people saying about these different extensions? And then the popularity, how often have they been downloaded? Get a sense of what the user community is really liking. And then we also have this little icon on the corner just to tell you whether it's been created by our JMP staff members. But we are also opening this up to all of our JMP users and community to be able to submit to the marketplace. So more to come for that. When I click on the add-ins, I really wanted to answer the question, is it going to work for me? So say I have JMP 18 and I work on a Windows operating system. I want to know right away, is this add-in something that I can use? So we have that right here in the corner for you. So we can see minimum JMP version, JMP 17, I'm on 18, I'm good to go. Supported hosts, Mac and Windows, I'm on a Windows operating system, definitely can use this add-in. We also added, so all of our add-ins will show some screenshots of what to expect when you download the add-in. When you install it in JMP, what should you see? So you can scroll through those there. Additionally, all of our add-in owners a lot of them have created new video content, so you can quickly see a video of how to use it, what are the data tables they're using, what's it going to look like when I use it. If you're not as much of a video person, you can also go down to the how to use section. We wrote out, how to use the add-ins, what do all the menu options do, what do the buttons do, what can I expect to see, and any kind of additional information or tips or tricks that might help you use the extension. Additionally, we have kind of our review interface here, so you can see what other people are saying about it, and we encourage everyone, if you like something, let other people know, leave a rating or review. And then additionally, if you have a question, we ask you, ask the question through here. We do send follow-up emails to all of our add-in owners to encourage them to respond. And when you're good to go, you can download those add-ins. We just ask you to sign the terms of agreements, and it'll just download directly to your desktop. Let's see if I'm still logged in. Nope, I am not still logged in. One moment. There we go. This is live demos for you. There we go. All right, I'm in. So we just ask everyone to sign in with their MyJMP ID, so similar to the community, the store, and a lot of our other JMP resources. If you're familiar with the JMP 18 authorization, the very same interface. And we just click download, we sign the user agreement, and we click submit, and it just downloads to our desktop as a JMP add-in. You would just double click on that add-in, and it will open within JMP. If this has inspired you to create one, we ask you to definitely do that. So you can just go to the Publish tab. We have a walkthrough here. We just ask you to tell us a little bit about your extension. How do you use it? What versions of JMP does it support? We upload the files, and we ask you to just attest that you are following JSL and Python best practices. And then it will be submitted to our product management team for review. Things that are submitted through the marketplace won't necessarily immediately go on the marketplace. We do a review in the background. We also do some testing. So if you tell us it works on JMP 18 on a Windows desktop, we're going to test it on JMP 18 on a Windows desktop to make sure there's no obvious errors, so when people download it, they get what they're expecting. Once I've submitted one, what can I see next? So I can go to my JMP extensions created dashboard. If I have any that have been published, I can see those on there. And I can see one I have in progress, it's pending review. After that, it will move to a file security check. So we do run malware scanning against all of our add-ins and extensions that have been submitted. Really just trying to make sure that anyone who downloads it isn't downloading they're not expecting. Same thing, we do kind of a code review similarly, just to make sure that nothing that anyone downloads would be harmful to their computers. And then it moves to that final phase where we do kind of a product management review, make sure it fits the Jump brand, and then some light testing as well. So this has been a very quick demo of the Jump Marketplace, but encourage everyone to try it out. I will be at Meet the Experts and around throughout the week, so go to the website, tell us what you like, tell us what you don't. It's still a work in progress, and if you're looking for extensions or add-ins that you'd like to see, let us know that as well. And with that, I will pass it back to Julian.
Thanks, Kristen. So before we finish up, I do want to acknowledge one thing, and that's that I've been, I think, a little bit dishonest with you, rhetorically speaking. You know, it's really easy in a presentation to talk about seeing discomfort and making a commitment to change, and then hopping right to the end point where you just show the thing finished. And so it's really easy to do that in the presentation, but it's not something you can really do in life, right? What we've kind of glossed over is the middle, that uncomfortable place between you and what you want, right? The place that's sometimes frustrating, sometimes hard, sometimes just boring and empty and time-consuming, right? The middle. And the middle is an important place because it's the place where we learn to grow, learn to make changes, learn to make the difference that we're trying to get to. And as I've been saying this whole time, you know, Jump is an incredibly great place to be in the middle because of all the affordances that it offers us, right? But the middle is hard, and you know, discomfort is, as it is defined, an uncomfortable place to be. And so what I'd like to do now is just remind ourselves, you know, we were thinking at the start about a thing that we might want to change, a thing that we want to be different in our work or even in our lives. And you know, if the thing that you want to change is something to do with data, I hope you can find time during this conference to talk to people here, talk to the community, and find a way to make that thing better. If that thing you want to change is something bigger, I hope you also find space in the community here to find the support you need. I mean, the Jump community, all of us, are quite supportive and here to be that kind of resource. And so as you move forward into the day, into the week, you know, I hope you reflect on that thing you want different, and I hope you find a path forward. Because I can't think of any better place to do that than at Jump. So with that, thank you so much, and enjoy Jump Discovery.